Hello, my name is Tanvi Desai, and today we are going to be looking into a classic machine learning problem. This is a classification task, especially a binary classification task, and we have a diabetes data set which includes parameters such as pregnancies, glucose, blood pressure, skin thickness, insulin levels, and BMI or the age of a person. And with that help, we are going to be predicting whether a person has diabetes or not. So it's binary classification, yes or no. And for this, we'll be using multiple machine learning algorithms or models. First of all, we have the KNN classifier, we have the random forest classifier, we also have support vector classifier, and logistic regression. So let's get to coding. Um, so for this first thing, we will have to import all the required libraries which are needed for running our model. So we can import pandas as pd, import numpy as np, import matplotlib as plt, import seaborn as sns. We can import the warnings as well. We can ignore the warnings. Okay, so we can run and check whether all of this is correct. Okay, good. So now the next thing that we need to do is, since we've already defined our problem, which is diabetes classification problem, and we have all these parameters to work with, and our model is going to actually work as just as how a experienced doctor who can look into your reports and your blood work and easily guess whether you have diabetes or not. We have to create this model in such a way that once we feed the required data, it would also give out answers like just as a experienced doctor. So in that case, we have this data set which we have gotten from the publicly available data. So let me upload it to Colab. So now, like when we are working with Colab, we have to usually upload it in files and then copy this path over here and then load that into our, so that CSV file into our model. So we have to get it as df equal to pd dot read underscore CSV brackets. We can put the path in quotes and yes, we can run it here. Okay, so that works. Now let's look into the data that we have. So let's do df dot head. Let's look into the top 5 entries in the data set. Oh, sorry, top 10. So yeah, so we have this is the index, and we have pregnancies, glucose, blood pressure, all of that in like all these different values. So let's also look into the last 10 entries. df dot tail, sorry, this is going to give us all the last entries. Okay, let us look at our data set. df dot shape, let's check how many rows and columns it has. Yeah. So our data set has about 768 rows and 9 columns. Okay. The next thing we need to check is the data types. df.d types. Okay, so these are integers. Most of them are integers and floats, and we do not have any categorical data in this. That's good. Next we can look into df.descri describe. So this is going to give us the total number of counts, the total number of records that we have, the mean value of this particular feature, and the standard deviation of this particular feature, the minimum value. This is the interquartile range that we have, and the maximum value. So similarly for all the features that we have in our data set, so describe is going to give us all those values. Next, let's look into the whether our data has any null values. So df dot is null dot sum. So this is going to give us the sum of all the null values in each of the features. Okay, so we don't have any null values in our data set. So our data set looks good. Let us look into the unique values. df dot n unique. Okay, so all our features have these many unique values. Okay, next let's check for any duplicate values. F dot duplicate. Okay, we do not have any duplicate values in our data set. So these are all the columns in our data set. So right now, since we have a binary classification task, and we also have the fact that we know that we have to predict whether a person is diabetic or not, I believe this is our y dependent variable. So let's group our data and see how many diabetics we have in our data set that we have right now. So df dot group by outcome. Let's just copy it from here. Dot mean. Okay, so this should be able to give us a rough approximate of the okay, yeah, so this is giving us the mean of all the um, people with diabetes and people without diabetes. So yeah, so we have this right now, and let us also check the count. df dot df of outcomes dot value count. So let's do a value count, and this will give us the count of people who have diabetes and who don't. Okay. So I hope this is clear that in this step we check the mean value of the people with the diabetes and mean value for all these features for the people with diabetes and the people without diabetes, and here we have the count of people in our data set which have diabetes and which do not. Okay. So I think we can move ahead onto our like the most important part. So right now we've already done the part wherein we have pre-processed our data. In our case, we did not have to pre-process the data since the data came in a very good format. It was good data, and we checked for all the parameters that we needed to check in order to confirm whether the data was good or not. And since we are done with that, let us move into splitting our data set into training and testing data. So we will usually split it in a 80 to 20 80% to 20%, 80% for training the data, the model, and 20% for testing the model. So let us do that. Data splitting from sklearn dot model selection that import train train test split. So train test split is something that we use in order to split our data. So let us get our value. So x, which is our independent variable, let us drop um, the outcome column. So let's do that. Okay. And we need to specify the axis, which tells us that we need to look into the columns. So y, which is our dependent variable, and let us give it the outcome. Okay, so now we have this. Let us check. Let's run this thing. Let us print our x variable. Okay, so this is all the data that we have inside our independent variable. You can see that we do not have outcome right now since we dropped it. And let us print y variable, which is our dependent variable. So now here you can see that we have outcomes in y. So I think we can move ahead onto the next part, which is data standardization. This is a very important part when it comes to machine learning, building a machine learning model, because since our model sometimes basically it learns with numbers and stuff, so it judges all the values that we are giving based on maximum and maximum minimum values. So in order to avoid that, we need to standardize our data into such a way that all the data that we are giving can be compared with each other, and not just because the glucose values could be 166 but something else could be 5, but it does not mean that they can be compared to each other. So that therefore data needs to be standardized, and we can do that with the help of standard scalar. So let's get into that. So we will have to import from sklearn.preprocessing standard scalar. Okay, let's assign scalar equal to standard scalar. Let's run this. Okay, next what we do is we get our x, so we get our independent data into standard format. So we need to get x train scale Okay, I think a very important part has been skipped. Sorry, we have to split our data. So we, in this step, we did get our data in the form of x and y, but we did not perform the train test split. So let's do that before we go into standardization. So for doing the train test split, we need to define x train, comma x test, y train, y test, which is equal to train test split in brackets x comma y test split. Okay, so test size would be equal to 0.2, that is 20% for the testing data, and we are also specifying the random state, which can be anything, any number, so we can keep it as 2025. Let us run this. Okay, so now we have our train test split as well. We can print these values and check how the data has been split. So let us print x train. Okay, and let's print x test. Okay, there we have it. And let us print y test. Sorry, y train. Okay, we can also check the shape of our data, which is x train, which has to have almost 80% of our data x train shape. So yeah, so it has around 614 data points, and x test has about, I think, the 20% of the data set. Yeah. So now, since we're done with that part, we can do the standardization now. Okay, since we have already called the standard scalar and we have assigned scalar as that, we can go ahead and use scalar, x train scaled equal to scalar dot fit transform x train. Okay, and we will also apply the same on the testing data, scaled equal to scalar dot transform x test data. Okay, so the reason why we apply a fit transform here and a transform here is that when it comes to the training data, we will get the mean and the standard deviation of that data and then perform the Z transformation, which will give us the data in standard format. And whereas even on the X test data, we will use the mean and the standard deviation which we found from the X training data and apply the same. Just apply the Z transform on our testing data. So there we have the X train scaled and test scaled. Now we can call the various models that we have. So since we need to figure out which would be the best model from all the options that we have in classification. For example, we have logistics, we have KNN, we have decision tree, random forest, and support vector machines, and in that we have support vector classifier. So let's call all the models. Decision tree classifier from sklearn dot ensemble. I think I'm doing a mistake here. Sorry. Random forest classifier. Okay, so we can also then logistic regression classifier. So this is a linear model. Import from sklearn dot sbm import svc, that is support vector classifier. Now we need to um, assign all these to value. So let's do that. So this k and c would be this one. K neighbors, decision tree would be c. Let's keep it as dtc equal to this. Let's get the random forest classifier as well. There's a mistake. No. Logistic regression. C equal to SVC. So now, in case of these um, algorithms, we also have some hyperparameters which can be altered. For example, in k nearest neighbors, in the classifier, by default it takes around 5 nearest neighbors. So let us do the same thing. Let's change that a little bit and make it 10 for now. In decision tree we don't have to change anything. Let's also change the same for random forest. Let's make it around 200. We'll keep the same thing for the logistic regressor, and for SVC we can make the kernel equal to linear. Okay. Okay, I think we are good. Let's run this and see if there's any mistakes. Okay, looks like there is a mistake here. Okay, sorry, this has to be in estimators. That is a mistake. Yeah, so n neighbors is for the k nearest classifier, and this for random forest it's the estimators and not neighbors. My bad. Okay, that should be good. Yes. Okay, since we have called the models already, we can perform the prediction task now. So in case of KNC. We have KC dot fit. We'll give it X train scale and Y train for the training part. Let's run this. Okay, so now we have generated our object. Let us do the prediction. KNC choose y predict equal to KNC dot predict X test scale. Okay. So next we need to check now we have the y pred, so which is the predicted data that we have. Let us check the values. Okay, so now in this case we have the classification, which is whether a person has diabetes or not, so that's represented by a 0 or a 1. So let us check for the performance of this particular algorithm, which is k nearest neighbors classifier. Let us import from sklearn dot matrix accuracy score precision score recall score and F1 score. These are our performance matrix for classification models. Let us run this. Now, in order to check whether our prediction is good for KNN, let us get the let's print the accuracy of this particular data. So let us get print accuracy score. So we give it the y test and the y predicted data in order for doing the prediction. Okay, so now since we've checked for the accuracy, we have this score of 0.74%. That means around 74% accuracy, which is there with our model, which is our KNC model. Let us check for the precision, recall, and F1 score as well. Okay, let us run this. Okay, so after checking our precision, recall, and F1 score, we have these following values. So our precision is around 87.5%. Recall is around 44%, and the F1 score is around 59%. So let's do the same thing for the other models that we have. Let us check for the next one, that is decision tree classifier. So let's get DTC dot fit. Let us give it the X train scaled Y train data. Okay, now let's predict accuracies dot predict. Let's give it X test scaled. Sorry. Let's do the same thing for this data. Okay, so now using decision tree, we have the following values for our accuracy, precision, recall, and F1 score. Looking at this, I feel they're almost performing the same unless it comes to the precision, which is a little better in case of our KNN classifier. Okay, let me do the same for the other models and get back. Okay, so right now we are also checking for the performance of the random forest classifier, and for that we have accuracy score of around 77.9%, precision of 80.8%, recall of 60.3%, and F1 score of around 70%. So let's check for the next, that is logistic regression. Okay, so for our logistic regression as well, we have accuracy of around 75.9, precision of 76. So as of now, we have the random forest regressor working, classifier working the best way. Let's check for the last one, which is the support vector classifier. So let's get SVC. So SVC dot fit. Let's give it the X train scaled data and the Y train data. Do the prediction. SVC dot predict. Sorry, Y red. That was also fine to do. Let's just put it into YPRED, and so that we can get all the accuracy values. Let's get this over. Okay, so now for SVM we have 75.9% as the accuracy score, 76% of precision score, and 60% of recall, and 67% of F1 score. So I think we should choose the best model, performing model here, and in our case it is a random forest classifier. So I guess we can go ahead and build a model which we have trained now. So now we have to take our trained model, feed it, give it our input data, and see how it performs. Or let's see what it predicts. So in our case, let us design the input data. Okay, so let us make a predictive system. So let's make a predictive system. Let's get inputs in the form of a list as of now, or a tuple, sorry. So let's get okay, so we have a couple of parameters. So first we have around we have pregnancy, so let's make it 3 number of pregnancies. Then the next one would be 166. Okay, let's get the EF dot column. So it will help us in knowing what data we are giving. Glucose blood pressure, let's keep that around 80s in 80s. So glucose was 166. Then skin thickness of around 17 units. Insulin. So then we have to give the insulin, right? Let's make it 185. BMI. Keep the BMI as 26. Okay, so now we have to give this diabetes function. Let's keep it around 0.6 or something. And we also have to provide the age. Let's keep the age as 47. Okay, so now we have this input data. Let's convert this input data into a NumPy array. So input NP. So we have imported NumPy NumPy as NP. So NP dot as array, and let's give it our input data. Let us reshape it into like one instance. So let's reshape this data NumPy array. So input data shaped equal to input. Let's copy this dot reshape to 1 comma minus 1. I think we have a little issue with the runtime. Let me just get back with that. Let us reshape our input data. So we're done with that. Now, once we're done with the reshaping of our data, let us also get it into standard format. So for that, input data standard data equal to scalar dot transform. We will just apply the transform in this case. So we have input data which is reshaped. Yes. Okay, so now here we have our input data in a standard format in standard scalar. Let us do the prediction. In order for us to do the prediction, we just need to call the model. So in our case, it's the random forest classifier. So we can just call it with RFC. So let's make this prediction equal to RFC dot predict, and in this we have to give the standard data which we have right now. Print it as if prediction of 0 is equal to 0, then person is not diabetic, else if it is equal to 1, then let us print that the person is diabetic. Let's run this. Okay, so based on our data right now, whatever we had provided over here, our model, which is the RFC, is predicting that the person is diabetic. So yes, in this way we have built a whole machine learning classifier for our diabetes data set. We have pre-processed our data, we have performed the train test split, we have performed the standardization of data, which will um, um, help the model in prediction, and then we have found the best model, and after finding the best model we have used the trained model in order to predict data like this. So now from here in our case, when we have any data which will give us all these values, we will be able to predict whether a person is diabetic or not. So thank you.